Manuel, is this the camera? Shall we start? Before we get to those here. So you want to speak? So I introduce, then pass on to, we do handover. And so we do the introduction, then news and then we do the presentation. Yes. Okay. Okay, you want to sit down? Yeah. Sit down. Sit down. Sit down. So, welcome everybody to the 16th International Conference on Computational Creativity. And with me here are Manuel Ferleiros and Artemis Moroni, who are the local chairs. I'm Pablo Gervas, I'm the general chair for the conference. And I'll just say a few words to introduce you, so because there are any newcomers to the series of conference, and then I'll pass on to the local chairs. So this community sort of started getting together in the year 2000. At that time, I was working on my first poetry generator, and everybody kept telling me that generation wasn't a good thing to do because no one was doing it and it would never get anywhere. And still, we stuck to our guns, and we got this series of conferences going, and the Association of Computational Creativity. By the year 2012, I managed to be general chair for the International Conference on Computational Creativity in Dublin. And at that time, we had already discovered a few things, as shown by the motto of the conference, which is organized by Tony down here, which was scoffing at mere generation for more than a decade. And at that time, one of the things we had discovered was that generation was actually very easy. And the difficulty was more in telling. You could generate thousands of things, and the difficulty was in telling which ones of those were any good. And not only that, there was also this other side to the thing, which was it wasn't just any good to watch your computer create things. There was an issue of how to sort of merge what you can do, what the computer can do, and this idea of co-creativity. And there was a lot of work on all of these things. And then all this neural stuff came around. And the same well-meaning friends that had told me that generation was no good had to swallow their words. But what they then started to say was, you must be really worried because everything you've been doing is now no use because the computers can now do it very easily. And I think at that point they were also incorrect. I think a lot of the things we've been doing for all these years are still extremely relevant because we still have the same problems even though the neural stuff is so good, which is how can you tell when the things they're doing are good and how do we interact with them to make the most of the capabilities of man and machine. So I think we do have a long way to go. And I'm glad to see some new faces. The series of conferences from the beginning has been open to all communities. We have some principles on that. We like people from other disciplines to come and contribute, and we try to be very open to newcomers and new ideas and new approaches. So I would ask all of you to take that on and try to be open with any participant that presents things that might be different from what you do. I think there's another thing I wanted to say, which is we have this small tradition, which is this is the German's rattle. It's a Mexican rattle. It started being used in the series of conferences in Mexico in 2011, organized by Rafael over there. And it's like the Olympic torch. It's ceremonially passed on from local chair to local chair. But the local chair for the last conference in Sweden could not make it to Brazil, so I've been in charge of passing this on to the local chair, which will then have to be passed on to the local chair for next year's conference. And with that, I pass on the word to to Manuel Faleiros, who's one of the local chairs.
Morning, everyone. My name is Manuel Faleiros. I'm here coordinator of NICS, the Núcleo Interdisciplinar de Comunicação Sonora, Interdisciplinary Nucleus of Sound Communication, or Sound Studies, if you prefer. And on behalf of the local organizing committee, I would like to sincerely thank everyone for the trust and the opportunity to host this important event here at Unicamp. So the Interdisciplinary Nucleus of Sound Studies aims to conduct scientific research integrating science and art over 40 years. In recent years, it has focused on areas of musical creation and analysis with computer support and performance and music cognition. With national and international partnerships, it stands out for its scientific research and artistic production of an interdisciplinary nature. So we're deeply grateful to the local organizing team and the local staff, led by Mr. Dante Pezin. Dante Pezin is here. Dante. Along with our team, Delson, Lucas, Paola, our students, volunteers, and entire support team from COSEN, the general coordinator from our nucleus here at Unicamp, and CDC, Centro de Convenções, whose efforts have been valuable. So special thanks also goes to CTI partnership, represented by Professor Artemis Moroni, without whom this event would not have been possible. We here at Unicamp warmly welcome all participants and wish you an inspiring Congress. And I would to pass the floor to my colleague, Professor Artemis Moroni, please.
Thank you very much. I'm so glad to be here. I'd like to tell you how I've arrived here. I just finished my master thesis and I was thinking about my doctorate. Since I worked at CTI Renato Arte, a technological center, it seemed logical to follow it in engineering or mathematics. But I love art, how to conciliate these interests. One day, I picked up the printed catalog from Unicamp. Sitting on the stairs of the basic cycle building, I flipped through the pages exploring all the doctoral options in engineering and mathematics. Then I discovered computational semiotics. At that time, semiotics was popular among artists, and I thought this field could connect me with them. I approached the advisor in semiotics and shared my interest. He suggested I take courses in computational semiotics and evolutionary computation. This was the first time evolutionary computation was being offered as a course at Unicamp. I had to complete a project. At the time, I was in contact with Jonatas Manzoli, and together we were developing Act Contact, a musical electronic tap show. Between lunches and sketches on napkins, at restaurant tables, we developed Vox Populi, an interactive evolution system for algorithmic music composition. I still have the napkins. I decided to write a paper on Vox Populi and submitted it to 2 journals. They were both accepted. So I moved my doctoral focus to evolutionary computation. When the advisor, Professor Fernando von Zuban, knew about my interest in art, he suggested I make computational creativity my doctoral theme. Computational creativity, I asked. For me, creativity was such an abstract theme in the human domain, I couldn't even imagine it in the computational domain. I believe my thesis was one of the first in the field of computational creativity. Recently, Vox Populi was mentioned in Leonard magazine as one of the evolutionary environments that revolutionized computational music. And here I am with these wonderful people, Professor Manuel Faleiros, now the DINCS coordinator, who bravely took on the challenge of hosting ICCC'25 here at NIC's Unicamp for the first time in the Latin America, and his faithful and talented right hand, Dante Pezin. Moreover, it was with great joy that I recognized among the participants some authors have been cited for a long time. I consider myself incredibly lucky to work closely with such talented people at this event, in a time when computational creativity has gained a significant boost with the rise of generative AIs. I'm confident that we'll have a fantastic week ahead. Thank you for this great opportunity. That's it. Thank you.
Thank you very much. And on that note, we can now hand over to Amilcar Cardoso, Professor Amilcar Cardoso, who will be chairing the first session. And we kick off and start. Yes. The posters? Yes, I'll hand over first to Hugo Gonzalo Oliveira, who's one of the program chairs, and will tell you something about the posters.
Yeah, just one note. On Thursday, there'll be a poster session, and we'd like to tell you that everyone can vote on the best poster. Then there'll be an award on Friday for the best poster. There will be a ballot. You can vote. We'll tell you how to do it. Okay, thank you.
So the Mexican rattle is used for moderation. You'll hear this. If you're presenting, you'll hear this when you're approaching the end of your time.
So, good morning. Welcome to the conference. We are starting the scientific program now. And the first session is on humor. It's a quite good way to start the day. The first paper will be presented by Márcio Lima Inácio. Please come here. The paper is also authored by Hugo Oliveira, and it is called A Full Pipeline for Context-Aware Pun Generation. Márcio? Okay. Technical details around. Just a moment, there's a small technical detail here. Okay, let's start. Let's have fun. Márcio Lima from University of Coimbra, Portugal.
Is working? Okay, right. So, good morning, everyone. I'm Marcio, and I'm going to have the honor of being the first presentation here in ICCC 2025. I'll present a paper called A Full Pipeline for Context-Aware Pun Generation. That is a result from my PhD with Professor Hugo Oliveira. So, first of all, I'm working on humor generation, and more specifically, I'm working on a very small subset of humor generation, which is pun generation. Most of research has been historically made on puns, which has a very specific definition. So here pun is a form of wordplay in which I have a sign that is ambiguous. It evokes more than one meaning. And this is a very constrained type of generation because we have to ensure ambiguity. And also here, I'm trying to generate based on a context to avoid generating only for the sake of generation. So it's even more constrained. And here's an example of a pun. So we have tell me music's a bad career choice one more time, and the person attacking with a violin, and the person responded, violin's not the answer, my friend. So generally, the methods for pun generation that we followed the trends of natural language generation. So we have rule-based systems, we have rewriting methods, and of course, machine learning, and more recently, prompt engineering and LLMs. And especially those last two, machine learning and LLMs, they almost all require a pair of input words, the pun word and the alternative word that we say, as an input. So they expect those ambiguous words to be already set up as the input. So here, for example, we have count as determining the amount of something, and count as in having confidence in something. And then from this input, the system generates the pun. The inept mathematician couldn't count on his friends. And then we have also the part of context-aware humor generation, that it's when we want to generate based on an input context, based on input text. So there has been people that explored that for non-wordplay humor, for example, with script. And we also have some work on puns. So for example, the work of Sun et al., they have this method that they extract some keywords, and then they identified from a list of keywords which ones are the most suitable to generate a pun based on the keywords from the context. And they do this through a classifier. But there's a problem here that we still require those pairs to be manually created, or at least beforehand, because they still need the list of the word pairs, the pun word and the alternative word, to select from there. And that's where my work comes in. So we proposed a full automatic pipeline for creating those word pairs instead of relying on a preconceived one. And so here we do not require any manually crafted word pair list. And of course, I'm working on Portuguese, which is my native language, and still under research when we compared it to English. So first of all, we have a step of keyword extraction. So we still follow the keyword extraction pipeline. And from that list of keywords, we identify which of these keywords are ambiguous in terms of homophones and homographics. So we are working either with the pronunciation or the spelling of the word. And we do this using WordNet. And from there, we have a list of word pairs that we can use to generate the jokes and finally select, for example, the best one. For keyword extraction, the first step of the pipeline, we use Keybert, which gives us keywords for the input text, and then we use some word embeddings to expand this list of keywords. So we select the top 5 closest words in the embedding space. And for example, here we have the headline, the price of Samsung Galaxy S'25 drops sharply with discounts at Samsung, and then it extracts, for example, Samsung Galaxy price, and then we can expand that and get to smartphones, Apple, LG, or purchase, and increases, for example. Then, the first part, we identified which words are ambiguous and which are in terms of how they're spelled. So we had those keywords, and we searched for their definitions using WordNet. And then from those word definitions, we calculate the sentence similarity using their sentence embeddings. And if the similarity is below a threshold, which was set to 0.2, then that word is considered ambiguous, and then we can have, we identified this as a pair of pun word and alternative word. So for example, we had the keywords venda, which could be either sell or blindfold. And then we have their definitions, so the general activity of selling and a cloth used to cover the eyes, and the sentence similarity between those two definitions is very low, so this word is considered ambiguous. For homophonic words, it's a little bit more complicated because we're working on the pronunciation space. So first of all, we get the pronunciation of the keyword from a grapheme to phoneme system, and then we developed a phoneme to grapheme rule-based system that gives us all the possible spellings of that specific pronunciation in Portuguese. So for example, we had the keyword chá with X, and then it's pronounced as chá, and we have all those different types of ways of writing chá in Portuguese. Then we filter which one of all those types of spelling are actual words. So we have chá with CH and chá with X, and those two are pronounced the same but written differently, but we still can identify that as a pair. And chá with CH is T, and Shah with X is the former monarch of Iran. And also, when we're working with the homophonic pairs, it also goes through that step of identifying the definitions and seeing if the definitions are below the threshold. For generating the actual puns, for generating the actual text, we focused on transformer-based models, so we fine-tuned the T5 model for Portuguese, which is PTT5, and also tried some prompt-based systems. We used OLAMA's implementation of Llama 3.3 and DeepSeek R1. And we tested a lot of different combinations, so we decided to include the definition of the words into the prompt or not, and also tried zero-shot and few-shot prompting. And here there's just an example of how the prompt was built, so just a part of it. And for example, a joke that I translated into English, but it still works in English, so it's, why did the asteroid go to the music festival? Because it loved rock and metal. For evaluating, we gathered 30 headlines, 15 from Portugal, 15 from Brazil. We had 27 of them resulted in word pairs, so they resulted in jokes. And we had a total of 124 word pairs, so that's more than 1,000 jokes. And we needed to select which ones to evaluate because this was infeasible. So we filtered only one joke from each headline and for each model. And we used we used a typicality, which was the probability of that being from a classifier, and also the semantic similarity between the joke and the headline. We had 24 participants from Brazil and from Portugal, and they evaluated the jokes based on funniness and how it's related to the input headline on a 3-point scale. And we made sure that each headline was evaluated by at least 4 people. Here are the main results. So first, most of the models were not that funny. They had more than 50% not funny evaluations. The best model was Llama 3.3 using only few shot without the word definitions. And we saw that consistently with all models, including the word definitions harmed the results. We also saw that doing few shot actually gave us funnier jokes. In terms of the relation of the text with the input headline, we saw that PTT5 was the best one, but it's still around 50% of not related ratings. And when we include the definitions, it harmed its results. So it was the less than. So, and also for zero-shot LLMs, including the definitions, was not the best approach. But when we are using few shot, it helped a little bit. We also did an agreement analysis to see if the people agreed with themselves. For that, we used Krippendorf's alpha. We saw that funniness has almost no agreement, as expected. And although that Lemma 3.3 had the best results, it had a very, very low agreement of 0.02. And when we see the relation, it is a little bit better, but the agreement's not very high, like 70% or 80%. So it's still a very difficult task to be consistent, especially when we're dealing with such texts that are close to nonsense. So it's very difficult to identify if the text is actually related to the input because it's borderline nonsense. So just as a reminder of what we did, we proposed a method to create the word pairs from an input text. We implemented a phoneme to grapheme system in Portuguese. We evaluated 10 natural language generation approaches for pun generation, and in terms of funniness in relation to the headline, and we saw that the few shot outperformed, zero and few shot outperformed fine-tuned T5 model, that including few shot is consistently better, that including word definitions was not that much, and we still require some work to ensure that the texts are related to the input headline. We also did a manual analysis. We identified the lazy pun pattern, which was proposed by Xu in 2024, and it's when the texts actually include two instances of that word, and each instance has a different meaning instead of just one instance of the word that is ambiguous. We also found examples of humor that does not emerge from that specific input word pair, and also interesting insights about DeepSeek's built-in chain of thought. And that's all, thank you.
Thank you, Marcio. Questions? Who wants to make questions? Or tell a joke?
Knock, knock. No, sorry. I was wondering, so you define puns by, like, the essence of them by two words or two meanings, right? Did you consider the combinatorics of it? As how many possible puns can you make in your language? And could you just brute force generate all the possible puns?
I mean, we could. It would be limited to like the dictionary. Maybe. I don't know actual puns, how many it would be, but like the word pairs, we could like brute force, for example, WordNet and get all words and see all of the words that are, and build all word pairs possible from there. And then it would be possible to at least have all the possible word pairs, of course limited by the resource we are using, the dictionary we're using. But actually puns, the texts, I'm not sure how to get all possible.
You can definitely optimize it, but yeah, but there would be a subset, I guess, of all possible pairs that would be viable puns, and so it's like it's an actual number. Probably you can.
Yeah, we could find it actually.
More questions?
Hi, I'm Spila Winter from Slovenia. Just one question I didn't understand. In your results, you did not distinguish between the polysemous pairs and between the homograph pairs. And I would imagine that these two types actually have a different mechanism in humor. Like, I don't know, I would imagine that the homophonic ones would function better in spoken language as opposed to the polysemous ones. So I was wondering whether in your results, in your experiments, you looked at the results also separately. And the second very brief question, I find it quite understandable that the inter-annotator agreement was so low. So I was wondering whether you calculated it for all annotators and whether you considered using pairwise agreement, which would maybe be more relevant to see how much people agree. Thank you.
Yeah, thank you. Yeah, it would be very interesting to see if the type of the word pair would affect the results. Unfortunately, it would not be so much possible in the experiments we had, because we had very few homophonic pairs. I think it was only one or two. Yeah, most of that. It's very, especially in Portuguese, because we have like a more direct correspondence of the writing and pronunciation. It's a little bit difficult to find words that are written differently and spelled and pronounced the same. So I do not have those results to show. And the second question was about the annotator agreement, right?
Yeah.
Yeah. We use that. We did not have the pairwise agreement. That's why we decided to stick with the Krippendorf's alpha, because we had missing evaluations. But it would be very interesting to include another layer of identifying like those people that had similar tastes, similar sense of humor, and see if they find it funny, the same things. Thank you.
Any other question? We have time to, because he was so economic in time. I have one. It has to do with the use of this kind of systems. Okay. As far as I understand, you are working with on a system that generates those an autonomous systems that generates the puns, and I'd rather prefer something that could interact with people and could dialogue with people and generate puns in the context of a dialogue. Do you see this kind of approach in a system with that kind of?
Yeah, and it would be possible because we are only relying on the keywords of the input. So here we decided to do it with headlines, but it could be from messages from that are shared with a person. So I think it would be possible to include that in, for example, a chatbot or something that people interact with. And of course, when we are talking about the generation part of the process, and we are talking about LLMs and prompting, we can have a lot of space there. We can evaluate. We could include, for example, the messages into the prompt, and also that the conversation would be more fluid and things like that. So I think it's possible to have some interaction there.
It produces in almost real time.
Yeah, it's
it is amenable for dialogue.
When we're talking about the homographic ones, that's very easy to have. When we're talking about the homophonic ones, that takes a little bit longer. So I think for have this conversation and working in real time, it would be better to leave the homophonic pairs out of the equation, because the generating all possible spellings for pronunciation takes quite a long time.
Okay, thank you. No more questions? Okay, so let's applaud Marcio again. And now the second paper will be presented by Tony Ville from University College Dublin, Ireland. His paper is called Me, Myself and Irony, modeling the deceptive creativity of irony with the large language models. I'm curious about that.
Thank you, Amlakar. Okay, I want to talk about irony, which is a particular form of humor that, like puns, plays with ambiguity, but is considered somewhat more complicated. Okay, so I won't go into a definition of irony off the bat, but I will talk about how I'm going to operationalize it. Problem? Okay, so I have this symbolic model called EPIC. Nice acronym. It means expected property of an instance of a concept. So we expect certain things of the things that we meet in the world, the concepts that we meet in the world. We expect steaks to be juicy, parties to be fun, philosophers to be serious, cakes to be sweet. And when those expectations are violated, then we have incongruity. And incongruity is an ingredient for humor. And irony creates this incongruity by playing with our expectations, typically by dashing high expectations and expressing criticism and disappointment. So we have this expectation that a certain property has a high sentiment, but in context, the context gives it a low sentiment. That context is then an ironizing context. Now, irony takes many forms in language. It is a mode of communication rather than a structure. So we need to control the way we look at irony. We need a kind of a fruit fly, a Drosophila for irony. And the fruit fly I'm going to look at is in linguistics called the XYZ construct. Basically, whenever you say X is the Y of Z, you have an XYZ construct. Now, some of these are literal. When you say Macron is the president of France, that's a literal XYZ. When you say that Donald Trump is the Albert Einstein of diplomacy, you have a figurative XYZ, okay, because Albert Einstein isn't a category, it's an individual. Here it's treated as a category. I think many people here would consider this to be irony. Of course, if you heard it on Fox News, you would know that they meant it seriously. If you heard it in the West Wing, you think they would mean it seriously, but we all know that it is clearly ironic. And this is the ambiguity of irony and of this particular form. By the way, this example was generated by GPT 3.5, basic ChatGPT. And we'll return to the generation of these things by language models shortly. Okay, but back in 2012, kind of flashback period here, I started studying XYZs at scale and collected a large corpus of figurative XYZs from Google, back when you could do that by sending whole enfilades of queries to Google automatically. And I collected 2,196 figurative XYZs from the Google search engine, which meant that they came from all corners of a very dark web. Okay, so here's the most common Y. Chuck Norris. Remember Chuck? Chuck Norris is a model of someone who is durable, tough, and dumb as an oak tree. So if you wanted to describe something as durable and tough but not very sophisticated, Chuck Norris was your Y of choice. Back in 2012, Ron Paul, I guess the father of Rand Paul, a presidential candidate, was the most frequent X in our data set. Ann Coulter, also known as Ann Trax, a very famous Fox News pundit. Barack Obama, going for re-election. Bill Clinton, Sarah Palin, and John McCain still in the news, and so on. And the most common Z was the 21st century, the NFL, the Republicans, the NBA, the left, and so on. So this is what human data looks like. Now, most of them are rather banal, but some of them were creative gems. Here's a creative gem. Red meat is the Donald Trump of cancer. It took me a while to figure this out. Basically, red meat is implicated in a great many cancers in the human body. Therefore, it is an aggressive builder of cancer, right? In the same way that Donald Trump was known as an aggressive builder in 2012 and is now just basically known as a cancer. But You get the idea here. Some of these can be quite sophisticated, quite complicated. This isn't irony. It is a slap in the face with a wet fish when it comes to humor, but it is very effective. Okay, so we wanted to get language models to generate ironic XYZs. And we wanted to see this as a test of mere generation. We know that language models in the current form have near miraculous generation capabilities. But are they still mere generators? Do they truly understand and appreciate what they generate within a particular domain? If we ask them to generate irony, do they really get the irony? This is my research goal here. So we begin by simply asking the LLM. I'm going to talk about GPT 3.5 to begin with, but I'll broaden my horizons to other language models shortly. And I'm not going to bias the XYZs towards irony. So I'm going to call this data set the neutral XYZ set. They're not being asked to be ironic. So we get just over 1,000 examples from 50 metadomains. The most common X is Elon Musk, the most common Y is William Shakespeare, and the most common Z is international diplomacy. By the way, when you get human XYZs, the X is often someone you don't know. It's someone local and parochial to the interests of the speaker. But when you ask an LLM, the X's are always famous. An LLM has no non-famous friends. Everyone is famous in an LLM. Now, when we look at the human data, here called the web data, we find an interesting phenomenon. Almost all of the X's and Y's are male. Okay, it's as if the internet is controlled by males, right? So we get 90% of the data is male focused, 10% or thereabouts is female. For the LLMs, we get a 2-to-1 break in favor of males, but it's still much better than the human data. So the LLM, although skewed towards male data, is much more balanced than human data. We also see that the XYZs are what we might call transphobic. I guess you could call them that, in the sense that X's and Y's typically have the same gender. We don't compare an X that is male to a Y that is female, or vice versa, except in rare occasions. We might say that, in one example, Britney Spears is the Michael Jordan of pop. I don't think you would ever say that Michael Jordan is the Britney Spears of basketball. There's just a bias built into the whole process. And the language models actually are better at this than the humans at eradicating this bias. Okay, let's turn to irony. To get the models to generate irony, we use prompt engineering and give them an example of what we mean to typify our definition of irony. Now, the example I've chosen to give the model here is Vladimir Putin is the Dalai Lama of world politics. This is my inspiring example, to use Graham Ritchie's term, and we ask the LLM to generate another 1,000 XYZs. And this is the data that we get. The most common X is Donald Trump and Kanye West, well paired. The most common Ys are Mother Teresa and William Shakespeare. We also get Banksy, who is a good comparator for someone if you want to denigrate their artistic ability. We get Dan Brown, not our Dan Brown, but the Dan Brown of the Da Vinci Code. Elon Musk, Kanye West again, Gordon Ramsay. Now, we get the same male-female breakdown here, 2-to-1 in favor of males, which is still much better than the human data. We also find that almost all of the ironic examples are cross-domain, which is to say, a politician is compared to a non-politician, a sportsman is compared to a non-sportsman, whereas in the human data, it's about 50-50, right? And even in the neutral data, we find that there is a strong preference for in-domain comparisons. So politicians to politicians, sports people to sports people. But when we ask for irony, the model goes outside of its domains, and it gives us many more cross-domain mappings. Okay, when we ask the model to identify the dominant emotion in each XYZ, we see that for the human data, the dominant emotion is admiration in 72% of cases. For the neutral examples, the dominant emotion is admiration in 95% of cases. Remember, these language models are trained to be polite and benign. But when we ask them to be ironic, the dominant emotion is admiration in just under 70%. Now remember how irony works. These things have to look complimentary and admiring, but they actually have to have a sharp blade hidden within, right? When we ask the language model to rate these emotions numerically, we find that the human data has an average positivity of 66 out of 100, an average believability of 48 out of 100, and an average fairness of 40, whereas the neutral LLM data has a higher positivity, believability, and fairness, and the ironic LLM data has lower positivity, believability, and fairness. So let's now turn to actually identifying what we mean by irony. Okay, so if we were to graph believability versus positivity for a statement, we would expect irony to be highly positive but have low believability. We need to be able to tell that the speaker is insincere. So this positive claim actually disguises a negative criticism. So the believability has to be low while the positivity has to be high. But some of these examples are quite complicated. Donald Trump is the Marie Antoinette of modern democracy. What does that mean? It's actually open to interpretation, right? The LLM says it's because they say the most ridiculous things, which is true. Okay, here are some examples of ironic outputs. Conor McGregor is the Mother Teresa of sportsmanship. That's clearly ironic, right? I don't think Mother Teresa ever tapped out. So we've got admiration as the dominant emotion, but low positivity, low believability, low fairness. Okay, so we need low believability, but notice how sometimes the language model sees through the irony and correctly identifies the low positivity. So it's going to be an issue for us. Lady Gaga is the Jane Austen of understatement. Again, I would say that's ironic. Industrial agriculture is the Godzilla of the countryside. That is not ironic. That isn't a sincerely expressed belief about the destructive scale of modern agriculture, I think. So we have a lot of stuff to sift through here. Can you please come and press this key for me? It has decided to be recalcitrant. There's no pen drive. We're going to work out our technical details. I do this for you. I am the sacrificial lamb up here. I hope you're working this into your timing there.
No. No way.
You're brutal, Amilcar. We've always said that. Okay, we have an advance. But it is a Windows machine. Okay, I'll take it, thanks. Okay. We get all the benefits of Zoom without Zoom. Okay. So if we were to actually graph positivity by believability using a scatter graph, we'd find that the mean human example is in this upper left quadrant, which we can call insincere praise. That is low believability, high positivity. The variance is quite large, though, across these examples. For the neutral LLM outputs, the average XYZ is in the upper right quadrant, which is high believability, high positivity, which we can call sincere praise, which is what you'd expect from a benign LLM that has been aligned with human values. And for the ironic outputs, the average XYZ is in the upper left quadrant, insincere praise again, but look at the variance. The variance is enormous, so there's a lot of stuff going on in that data set. So what we want to do, given that we can look at the ironic outputs and say, that's not ironic, that's just sardonic. That's not ironic, that's just angry. That's not ironic, that's just confusing. How do we get the LLM to generate irony and then be secure in the belief that what we've gotten from the LLM is indeed irony as opposed to mere generation of irony? Can the LLM itself filter its own results, which of course is the acid test for computational creativity, and it's what separates CC from generative AI. So let's try a little experiment. Let's see if we can identify a property that the LLM can itself measure from the outputs, its own outputs, to separate the ironic from the neutral data sets. Is there some property that it itself can assess that we can then use as a guide to whether the LLM has given us what it thinks is irony? So if we ask it directly, how ironic is this? Ironicity, that purple line that hugs the random dotted line, we find out that the LLM's judgments of irony are terrible. They're just random. When we ask it to rate sincerity and use that as a division, we get much better separation. This, by the way, is an ROC curve. We're mapping 1 minus sensitivity to irony versus specificity. And of course, what we want is a curve that hugs the upper left corner of the graph in an ROC. The dotted line is random performance. The best performance we get is using believability and positivity together. In fact, 1 minus believability by positivity. And this has a name in the literature. It's called pragmatic insincerity. Someone is insincere, but in a way that is designed to be perceived as insincere. Therefore, they're not really being insincere. When you're ironic, you're not lying. You want people to see through the irony to what you're really communicating. So it turns out that the LLM, when asked directly, is this ironic, is a very poor judge. But when we ask it to judge believability and positivity, and we use that to separate the data, it's a very good judge. Okay, so finally, I haven't spoken about the meaning of the irony. What does it mean to generate something meaningful as opposed to something that looks like it's ironic? Well, in the case of the Trumpstein example, Trump is the Einstein of international diplomacy. What does that mean? Well, to an ironist, it means that he's an inept or unskilled diplomat. So we're taking Einstein as a counterexample. But to a Fox News advocate, so a non-ironic interpretation would be that he's a brilliant, super intelligent, stable genius of diplomacy. Now, if we get the LLM to generate these interpretations for us, and then get the LLM to rate the sentiment of those interpretations and get the difference between them, we call this the ironic parallax. This example has a parallax of 85, which is very good. Or we could simply take the sentiment of the ironic interpretation and subtract it from the sentiment of the Y, in this case, this good old Albert. And we call that the downshift, which is what we measured with the epic theory. And it turns out that the smallest downshift is in the ironic data, and the largest downshift and the largest parallax is in the human data. What does that mean? It means that the human data has the most capacity for irony, but the believability positivity landscape doesn't urge us to look for that possibility. So irony is a combination of low believability, high positivity, and double meanings that are there to be sought out when you identify the low believability. And finally, we replicated the experiments across a wide range of LLMs, and we found that the best LLM was Llama 3 70 billion. Much better than GPT 3.5. But even then, only 20% of the ironic outputs actually were self-identifiable as ironic by the LLM. But that's still far better than the 5% of outputs from GPT 3.5 that were self-identifiable as ironic by the LLM. So, to conclude, thank you, Amilcar. The question of mere generation is still with us. Just because the generation is so much better doesn't make it any less mere. The upside is that if used in the right way, the LLMs can move from mere generation to self-aware generation and meet the criteria of what we in the community call computational creativity, which is knowing generation of results that you stand over and can explain as creative, explain as meaningful. But you do have to apply the right tests in the right prompting framework, and that's all I have to say. Thank you.
Well, with this delay, we don't have time for many questions, but if anyone...
Not too many questions.
Not. Okay.
Thank you. Spela Winter from Ljubljana again. One perhaps comment. We've recently performed some sort of a crowdsourcing experiment. What I wanted to mention is that the human baseline for recognizing irony is surprisingly low. In the experiment that we've performed, it was around 0.8 accuracy for humans. So maybe the LLMs are not doing so poorly after all. But the real question was, when you were using the LLMs themselves to evaluate their own capacity of generating irony, did you experiment with any different prompts or a few short contexts, or also what was the technique used for this?
Okay, just to respond to the comment, thank you for that. Yes, irony is meant to be challenging, and humans are not meant to be perfect at it, because it is a mechanism for dividing audiences into those who get it and those who don't. It is much more of a challenge than a typical joke where you would expect or hope that the whole audience gets the joke. With irony, you have a target subset of the audience that you want to get it, and you have a non-target part of the audience that you hope will not get it. And that is why it still proves challenging to humans and, of course, to machines. When I first started hearing about LLMs and they were impressing themselves upon our collective consciousness, I proudly claimed they will never handle irony because they think, to the extent that they think in words, what they say they think and what they think they say, whereas with irony you have to have a thought that is distinct from what you say. Of course, I was proven wrong almost immediately. They're very good at irony, they're very good at lots of creative tasks, except humor, it's still a challenge. Okay, so to the prompt engineering, we use one-shot prompting. So in the example of irony, we give the Vladimir Putin as the Dalai Lama of world politics, and we give a different example for non-ironic prompting. But in both cases, we use one-shot prompting. And we also give something of a meta explanation of what we expect from irony, which is that it is a veiled criticism and so forth. And the language model is pretty good at that. Something I will say is that we were surprised by how creative the ironic examples were compared to the non-ironic examples. I think if those of you who are familiar with language models know that when you ask a language model to be creative, it doesn't really respond well to that prompt. It tries to work the idea of creativity at a meta level into its output. So it will talk about creativity rather than being creative. If you want an LLM to be creative, don't use the creative keyword. Use words like irony or cynicism, right, or sardonic. You need to use creative adjacent words to get the best out of your language models. And we see this with the irony examples, that they're much more creative than the non-ironic examples because they have much more domain distance, more domain incongruence, and so on and so forth.
Okay, let's thank Tonyville again. And now we have the next session. Oh, it's coffee break. Still better. Let's have the coffee break. We are almost on time. 3 minutes of delay. Huh?
And it's all down to the right key on the keyboard. Thank you for your patience.
Okay.
Yes. Hi, everyone. Welcome to the LLM session. I'm your chair, Milka Traykova. I'm a research scientist at Georgia Tech. We have 3 papers, I believe, in today's session, and I'm going to butcher the last names, so we agreed to only do first names. So the first paper, titled Refining Metrical Constraints in LLM-Generated Poetry with Feedback, is written by Manej and Hugo. Welcome to our first paper.
Okay, thank you. Yeah, this paper is work by me and Mane Shakiret Sabal from the University of Copenhagen. We've been working together for some time. He was in the conference last year. And this is kind of a follow-up of the short paper we presented last year. We all know that LLMs generate poetry nowadays that is, well, good enough when compared to previous work where we use templates and other rule-based approaches for generating poetry. But still, they have limitations, and there are many works that study these limitations. There are limitations on diversity, for instance, and also, among others, limitations on the target format that is not always met. So we ask for a poem with specific features, and these features are not always met by the generated text. And we decided to start to analyze to what extent this was a problem. And last year we started to study simple things that are features that are easy to measure, like the number of lines and the number of syllables. And we noticed that even a thing that is as simple as the number of lines was not met in several situations when we asked the LLMs for generating a poem. We also noticed that LLMs, well, everyone knows this, they can keep a conversation and consider past interactions. So we thought that maybe we could try to refine the results of LLMs. So we interact with them and say what they got wrong, and hopefully in more than one iteration we get a better result, or at least a result that is closer to the features that we want the poem to meet. And so this is the goal of this paper, and the experimentation that we perform is on this. So we explore automatic iterative post-hoc feedback for guiding the generation of metrical poetry with LLMs. We focus on the number of lines and syllables. This is our focus, this is our goal, but we also do some very short analysis of the impact of meeting these numbers on rhymes and diversity. So 2 features that are also common, well, rhymes are common in poetry, and diversity is also important, right? We don't want the LLM to generate always the same poem for the same input. So this is our approach. So we have the prompt with the metrical features. We have an LLM that will generate a poem. Then we analyze this poem by an evaluator, which can be another LLM or a tool, a rule-based tool for analyzing poetry. Then we generate a prompt with a feedback. We send it to the generator, and hopefully the generator will generate a better poem, which will be evaluated. And after some iterations, we can get to the poem that meets all the constraints, or at least is closer to meeting them than the original poem. So to generate, the prompts are quite simple. We ask the system, the LLM, to generate a poem and give it a number of lines, possibly a topic, if we want to, or we can also say the number of syllables that each line has to have. And then we evaluate the poem, and yeah, this is more or less what I just said. If the constraints are not met, we give the feedback, we prompt the generator to create a new poem, and we go back to step 2 to evaluate the poem. And if all constraints are met, or a certain number of iterations is reached, we stop and analyze the result. So in order to evaluate the generated poems, we count the number of syllables and the number of lines in the poem to see to what extent they are the numbers that we asked for. And we can use tools like LLMs following the paradigm of LLM as judge. And for this, we have a prompt. We noticed that for the number of lines, for some reason, the chain of thought style prompt works better, so that's why we have this prompt. For counting the number of syllables, we adopted some previous prompt in the literature that explains what a syllable is, and then we ask the model for counting the number of syllables. And yeah, if the poem does not have the target number of lines, we generate this text or use this prompt for telling the model that there's some problem. Or the same for the number of syllables. So we performed some experimentation with 2 LLMs. We used both of these LLMs, Llama 3.1 and Gemma 2, in a quantized version in order to generate the poems. So they are both general purpose instruction tuned LLMs. They are not fine-tuned for generating poetry. And we used 3 evaluators. These 3 evaluators are the same, 2 of them are the same models that we used for generation. And the third one is a rule-based tool that we have developed a few years ago. It's a rule-based analyzer that can be used for things like counting the number of syllables, counting the number of lines, analyzing the diversity in the collection of poems, analyzing sentiment and other features that we're not using here. Here we are focusing just on the number of syllables and number of lines. And well, we also use it later for the rhymes and for the diversity check. We set 7 combinations between the number of syllables and number of lines. The first 4 consider only the number of lines, and then the last 3 we focused on 4-line poems, and we have different numbers for the syllables of each line. So 8 syllables, 10 syllables, and 13 syllables. We also decided to try this with different topics to have a higher diversity of solutions that we could study. And first we selected 3 topics that are popular in poetry, 3 frequent words that are not common in poetry, and the 7th is no topic. We don't ask the model to generate poem on any topic. By the way, we these words also by asking a model for this kind of words, and these are the first 3 for each type of topic, let's say so. Oh, and we also tried 3 different values of temperature in order to analyze if this parameter, which has been studied and also regarding computational creativity, if it had any impact on the results that we were getting. So the higher the temperature, the less deterministic the model is, so this might have an impact on the results. In the end, we got a total of more than 3,000 interaction sessions, which we saved and which are available. And you can use them for studying other features, or anyone can use them for analyzing our data. Just to show you how an interaction session is, so we start with that prompt where we ask the model for creating a poem. We give the model the constraints, which are part of the prompt, and we get a poem. Then we use one of the evaluated tools for analyzing the poem. And in this case, no lines. So there are 4 lines, but none of them matches the number of syllables. So that's what the feedback contains. So the first line is 9 syllables and should have been 13, and so on and so forth. And we keep on this for several iterations until in the end, in this case, I'm not sure if I'm not going to count the syllables. It should be close enough to the number that we wanted in the first place. But this is all done automatically, of course. This is just to show what happens underneath our scripts. And so once we have all these sessions, we can analyze, for instance, how often feedback is necessary. If it's not necessary, it's because the model is already good enough at generating the poem with the target constraints in the first place. And we see that about half, slightly less than half of the times, no feedback is necessary, which is okay. And we also notice that there's no impact of temperature. Regardless of the temperature, 0, 0.1 or 0.7, the numbers are more or less the same. What matters the most is the model that generates the poems and the model that evaluates them. But then, so I recall that we had 7 different combinations, 4 of them considering just the number of lines, and 3 considering the number of syllables. And we decided to analyze just considering the number of lines, and we see that the models are quite good at generating poems with a specific number of lines, at least until 8 lines. When it comes to 14, it's not as good. This is interesting because, of course, it's a very simple constraint, but last year we showed that this was not always the case. We used the previous version of Lemma, and we showed that in many cases it did not count lines properly. So there is an improvement with the most recent version of these models. But the challenge is not on the number of lines. The challenge lies on the number of syllables, which makes sense. It's more difficult than number of lines. And here we see that almost every time feedback is necessary, regardless of the number of syllables. And so these are the ones that we focus on to show whether feedback is useful or not. And it seems to be. So feedback seems to be effective. These plots show for different combinations of evaluator and the generator the improvement, the evolution, which is in most cases an improvement on the number of syllables. So first with where we have the bag, it's the beginning, it's the first iteration. So the average, this is the accuracy. So the accuracy is quite low, the average accuracy, but then with feedback in the middle, it keeps improving. And in the case of Lemma, with feedback by Erato, the rule-based tool, we got almost 100% accuracy when it comes to matching the number of syllables. This is the best combination, but in most of the others, we see improvements, sometimes more pronounced than in others, but we see improvements. So feedback is indeed effective. And as I told you, then we look at the impact on rhyme. So depending on how the model would change the poem towards meeting the desired constraints, it might be changing things that will have a negative impact on the poem. And what we see, we looked at the results by Lemma and by Gemma, and we see at first that we need to stress this. We're not asking the models to generate poems with specific rhymes. No, we're just asking them for generating poems. And we see that Gemma has a higher trend to generate lines that rhyme than Lemma from the beginning. And on top of this, we see that the Gemma poems do not seem to be affected by the improvement when it comes to the number of syllables. So the rhyme density is more or less the same in the beginning and in the end. It's actually, on average, slightly higher. When it comes to Lemma, the improvement in the number of syllables is done at the expense of lower rhyme density. So it is affected. I think I said this. And we did a very quick analysis just to see what happened for this to happen, and we have an example here. So we have this poem that had that third line, fast and free, that would rhyme with me, and when we gave feedback to the model, it changed fast and free to free now. So we got no more rhymes. When for Gemma, it changed more than just the ending of the line, and the rhyme was kept. We also looked at the impact on diversity. So for some, or for all the topics, we had 5 generations, and we could compare the diversity or the overlap of the poems generated for the same topics with the same constraints. And we noticed that in this case, in opposition to the rhymes in Llama, in this case, the diversity is more or less the same, so it's not affected. It's not a thing that, in the end, we tend to get always the same poem. So diversity is stable in the first iterations and in the last. So to conclude, we have seen that general purpose LLMs in this range that we tested, 8-9 billion parameter range, are up to produce poems with specific number of lines, which is an improvement in the most recent generation of Llama, because that's the model we had studied last year. But we confirmed that they keep struggling when it comes to meeting a given number of syllables. But this can be improved with feedback. And feedback has been used for other tasks, and so we tried to apply this also to this task, and we confirmed that feedback is positive, it is effective for our goal. And yeah, this is a rule-based poetry analysis tool can be used here. Of course, we can also use LLMs as judges, but for the sake of transparency and yeah, mostly transparency, and also what's the efficiency, rule-based tools can be useful here. And yeah, with feedback plus this tool, most generations of Llama 3 converge to the target number of syllables, and this was achieved often by changing the end of lines, which had a negative impact on rhyme. And we have the data set with all the sessions. It is released for future research if you want to check it. And in the future, with this data set or with other experimentation that we might perform, there's lots of interesting things that we can do, such as exploring other constraints, other combinations, more complex than just the number of rhymes and the number of lines and the number of syllables. It would be interesting to try other combinations like the rhyme pattern, or the topic, or the sentiment, or wherever. And that's it. Thank you. And this is a picture of me and Manesh that I could find in my laptop. Or can you use this?
Thank you. It's interesting that you notice that dealing with the number of syllables is difficult, and at the same time it's easily explained and probably very difficult to solve, because LLMs, they don't work with words, and they don't work with syllables, and they don't work with characters, they work with tokens. They actually chop up everything into tokens and then put tokens back together. And there's no match at all between tokens and syllables. So for them, it's actually very difficult to deal with a concept that they cannot represent. Are you ready to accept that this may not happen at all? That you may need something different to work at the level of syllables?
Yeah, why not? This is just to show the limitation of the general purpose LLMs. I would argue that the larger LLMs might work better with this, and also depending on the training data. And there are also other LLMs that are trained on tokens that are syllables. There's some work, and there are also languages that, for instance, Chinese, where you have the character base, and it will work better. So for the languages, for English in this case, and for many other languages, and using the general purpose models, this will be challenging, and probably will keep like this, possibly with minor improvements depending on the training data, of course. But it all goes back to the tokenizer, and if the tokenizer is not based on syllables, it will not be solved.
Great, thank you. Do you have
Have you tried to solve this problem by maybe prompting for a special type of poem? Because I think there are some poem types where it is more important to have the correct number of syllables, and for other types it's non-important at all. So maybe that could help. Have you tried it?
I'm not sure if I got your question right, but we just asked to generate a poem with a specific number of syllables and lines and then syllables. So we don't ask for a specific type of poem. You mean if we asked it to generate like an English sonnet or a limerick or an haiku? We didn't try it, but it could be something interesting to do.
Okay.
Yeah, thank you. I guess that it might, or some of the models might have seen prompts like that with the name and then result. And I don't know if the poems would be that creative, but the number of syllables might be right.
The technique that you showed us reminds me a lot of genetic algorithms, where you have a sort of generator and an evaluator, and you pass it back and forth. But then, of course, it's with large language models. Did you see with this technique as well that there's this sort of initial improvement that goes very quickly, that sort of flattens off at the end? And is there a sort of optimum amount of iterations where the amount of increase, the amount of improvement sort of stagnates? Is that something that you saw in your experiments?
No, we just decided that the maximum number of iterations would be 10, and the plots are for 10, even though in some cases the poem, so we did not reach the number 10 of iterations. Sometimes it stopped earlier because the number was matched. We didn't try, it could be interesting, yeah. We didn't figure out if there was an optimal number of iterations. For sure, in some combinations, it will be higher than 10 because they are still not on top.
Yeah. Can I do a follow-up? Okay. And I was also wondering if this is a sort of robust technique that's also applicable in other text-based tasks, such as now you're doing poems, but maybe you want to ask the LLM to give driving instructions or other type of instructions. Do you know if this technique has been used before to sort of try to maximize its output by using multiple iterations using this technique?
It has been been used in several tasks. I don't know about its usage for this specific one, but there are some papers. We have some references in our paper. I know of some, for instance, in code generation, where you give feedback in order to improve the code to do what you want. But of course, this takes advantage of the inconsistency of models, right? So when you ask them for the same thing more than once, if they haven't seen that much kind of data, they will generate something differently. Yeah. So we can take advantage of this and try to guide the model towards the right answer, the right direction.
Yes. All right, thank you.
Do we have any other questions? No? Okay, I have a question. Who are your intended target users for this tool? And as a follow-up to that, I know you mentioned at the end that you're interested in exploring other types of feedback elements. I was curious if you've considered talking with domain experts, such as poets, about what are the elements that they consider to be most important when evaluating a poem.
Yeah, starting with the last part, that would, of course, be very interesting, challenging, because it would require time, but it would be obviously be very interesting. About the target users, this is not really a tool. This is, so we propose this approach, but it's not a tool. It's our experiments try to show several things. One of them is that show that there is this clear limitation in general purpose LLMs, and we also want to show that rule-based tools can still be useful in some situations, for instance, when combined with LLMs, or used alone for the analysis of poems. That's the main goal.
Okay, great. Anyone else? Okay, let's thank our speaker.
Okay. Thank you.
All right, our next paper is written by Robert Morin and Dan Ventura, titled "Is Prompt Engineering the Creativity Knob for Large Language Models?"
Okay, thank you. This is actually work by my PhD student, Robert, who's right here. He should be giving this talk, but he just had a baby 2 days ago, so he's not here, and I'm going to give it for him. This paper was inspired by a paper from, I think, last year's conference by Max Pieperkorn and his co-authors that got quite a bit of attention, and it was a really interesting paper. Is temperature the creativity parameter for large language models? And in that paper, they asked the question of if we change the temperature parameter in an LLM, does it make the LLM more creative in essence? And that's a really great paper. You should go look at it. The punchline is basically the answer is no. Even though the temperature parameter is sort of advertised as the creativity knob for an LLM, they found, in fact, that it doesn't work like that, unsurprisingly, because it's a very simple parameter, actually. And so, having read that paper and thought about that, we thought to ourselves, okay, well, if that's not the right knob to make, to be able to control the creativity of an LLM, what would be the right knob? And LLMs, in general, don't have a lot of knobs unless you get in and play with the actual code or the parameters, and obviously most people aren't able to do that, and most models, or many models anyways, are black box, closed, proprietary. You don't have access to that stuff even if you are able to do it. And so the only other real knob we could think of besides temperature is prompting. And it's not a very well-defined knob, it turns out, but we still wanted to ask this question: how does prompt engineering affect creative output of LLMs? Is there some knob-like property, or is there something that we can sort of quantify or study or look at that says, as we do this with prompting, the creativity gets worse or better or something like that? So that's kind of the goal of this paper. And it's tricky because in the original paper with the temperature, it's a really knob-like parameter. It kind of ranges from 0 to 2, and you can just search through that space of this one scalar value and see what happens as you change that to the creative output of the LLM. But for prompting, there's nothing like that. You have this really combinatoric, sort of geometric combination of the vocabulary compounded as much as you, I mean, you can make huge prompts if you like, and so the prompt space is gigantic, and there's no sense of here's the smallest prompt and here's the largest one, here's the simplest one, here's the most complex one. It's really tricky business to think about, okay, how do we think about prompting as a knob? And what we came up with, instead of trying to study all the prompts, which of course is impossible, is to look at 4 classes of prompts that sort of range from simple to more complicated. A basic prompt, like the very first thing that anybody would think of to put in for the model to do what they want it to do. Then a human engineered prompt where you're sort of being intentional and you're kind of clever about how you prompt the model, hopefully. And then a prompt optimization technique, which we'll talk about more later. And then finally, chain of thought prompting, or chain of thought reasoning, really, letting the model sort of prompt and reprompt itself. So we're going to study these 4 different prompt classes, if you will, prompting approaches, as the sort of settings for our knob to turn. And we're going to look at 4 different domains in which we will apply this knob setting business to try to see how does the LLM behave. These are the 4 domains that we're going to choose. Jokes, poetry, 6-word stories, and flash fiction, which is defined to be short stories that are, I think, smaller than 1,500 words. This is how our study design looks. We're going to generate We're going to generate 100 artifacts. We are going to have a system that does automatically evaluates these artifacts to try to say how good they are, creative, novel, quality. And then from that automatic generation, or that automatic evaluation, we're going to select the top 10, and then we're going to, in each domain, and then we're going to ask people to do evaluations, 2 different types of evaluations, which I'll talk about in a minute, for those, and that's how we're going to sort of look and see, all right, how's the system doing? It's pretty complicated. There's a lot of stuff. I'm going to have to run through it quickly. Please have a look at the paper for all the details. This step, the automatic evaluation step, works like this. We generate an artifact using an LLM. We have a template into which we drop that artifact, and then we pass that populated template into GPT-4o and ask it to evaluate the artifact. And I'll show you what I mean in a minute. And then we parse the response that it gives, and we get a score as that's the automatic evaluation. So the thinking is sort of like what Tony talked about in his talk, that the system ought to be able to say something about what it has created, and it ought to know something, well, hopefully know something about if it's funny, if it's a joke, is it funny? The system should be able to say whether it's funny. That's what we're asking. So here's an example of a joke prompt template for one of the characteristics that we ask about quality. For jokes, that quality is funniness, and so we tell the system, you're an expert in humor, blah, 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 blah. How do you feel about this following statement? This joke is funny, and your options for replying are strongly agree, disagree. So it's a Likert scale. We're giving this Likert scale to the LLM and asking it to respond using just that Likert scale. This, by the way, is exactly the same scale that we're going to ask the people, the human subjects, when we ask them to evaluate the jokes later, too. And there's something like this for novelty, and there's something like this for directly asking about creativity, and there's something like this for every one of the domains that we're asking about. So this is our algorithm number 1. This is our automatic evaluation algorithm. You can see that we're doing this drop into a template, fill the template, ask the LLM, parse the response, get a scale, and we do it for 3 different characteristics. That's not working. 3 different characteristics and average them. That's going to give us our score. This is the automatic evaluation that the LLM does for the artifacts to sort of decide which ones it thinks are the funny ones or the emotional ones or whatever. So we're going to use that in a couple of places. So we have 4 domains, and we have 4 kinds of prompting. You'll remember this is the simplest version of prompting, very basic thing that you might expect. Write me a joke. The joke has to be new and original, and we want the jokes to not be very long because we don't want like long form pages jokes, because we want to get to it, and we want them to not take too long for people to evaluate. The second level is prompt engineering. This isn't a full prompt, but this is the kind of things you might put in a prompt to try. Hopefully you're kind of familiar with prompt engineering now. So we did some work to try to make good prompts that really get the LLM to think about what it's doing and produce good results, better than the basic ones. Okay, the third thing, this is going to take a minute, automatic prompt optimization. This is a system that produces the prompts instead of people producing the prompts, and it's supposed to produce the prompts in a way that's effective and flexible and black box appropriate so that you can use it for any LLM system. And we used this model by Deep Thought called OPRO for optimization, prompt optimization, and we used this system that they had. And the way this system works is it's good for doing whatever you want it to do. It generates solutions. It scores them using some kind of function evaluation, and then the solution score pairs are dropped into a meta prompt that says, come up with better prompts to produce better solutions, and it goes around and around until it has a set of really good solutions. So its job is to come up with better and better prompts, to optimize the prompts to generate better solutions, whatever task you're having it do. For us, the tasks are to produce prompts to produce jokes, or to produce prompts to produce short stories. So we're asking this system, we're trying to we're using a meta prompt to produce prompts that will produce jokes or stories or whatever. And this is the kind of thing that it looks like. It's a fairly long, drawn-out process, and the details here aren't that important. It's a meta prompt. So as it goes around and around, it gets more and more examples of these kind of prompts and scores of how good the prompts are. And then at the end, it says, now give me even better prompts that will get even better scores. And to do creative artifacts, for us to do this, we need this, how can we automatically evaluate the things that are produced, the jokes, the stories? And we already talked about how we're going to do that. We're going to ask the LLM, how funny is this joke? And that's using this part right here, this score, evaluate, artifact. This is that algorithm 1 I showed you a minute ago. That is the automatic generation for the LLM to tell you how good is it doing. So with that, the LLM can decide, how am I doing? Is my prompting method producing funnier and funnier jokes? As it goes around the loop, it's coming up with a better prompt to get better jokes that are scored better, and it goes around and around until it gets good enough jokes or good enough stories. So that's that. And if you look over time, you can see that it does, in fact, improve the self-evaluation. Remember, this is all automatic evaluation by the LLM. It improves its evaluation of the jokes or the stories or the poems over time. We ran this optimization loop for 100 steps, so it produced for 100 times better and better prompts to produce better stories or better jokes. And we looked over the full 100 steps and picked the prompt. This is a score for how good the prompt is at producing 6-word stories. We picked the prompt that got the best score, averaged across a bunch of stories that it created, and said, that's our really good story-generating prompt. And in all cases, this optimization thing, this isn't our work, this is Google's work, optimized that prompt so that it created better stories, better jokes, better poems. Better in the sense of what it self-evaluated, I should say. And you can look in the paper for these. We don't have time to read these, but these are the best prompts for each of the 4 domains. These are the prompts that scored the highest across those 100 steps for each of the 4 domains. There they are. They're pretty nice-looking prompts, actually. Okay. For the last kind of, so we have basic prompting, we have human engineering prompting, we have this automatic prompt optimization. For the last kind of prompting, we use chain of thought reasoning, and for that we used DeepSeek, because it was rated the best a few months ago for a lot of things. So that's what we use for chain of thought reasoning. We started the chain of thought with the same basic prompt that is our first kind of prompting, the basic one. Just write me a joke, blah, blah, blah. And then the chain of thought reasoning happens, blah, 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 blah. And then at the end, out comes a joke, or out comes a story, or out comes a poem. That's prompting technique number 4. Okay, so now we have this system. It has 4 different ways to prompt for 4 different kinds of domains. And now we want to see, the question that we have is, for the different kinds of domain, or the different kinds of prompting, as we turn the knob to more complicated kinds of prompting, do we get more creative output? That's the question that we're trying to ask. And so to do this, we're going to, for every domain, for every method, we're going to generate a bunch of artifacts and automatically evaluate them and pick the best ones and save those best ones and then run them through a human survey. And that's going to be 160 artifacts. That's 4 domains times 4 methods times 10 of the best for each one. That gives us 160 artifacts to evaluate. And we're going to ask people to evaluate these in two different ways. One of them is a characteristic evaluation. This is the exact same questions we ask the LLM when it's doing the automatic evaluation. Is this joke funny? Is this story emotional? Is this original? Those kind of questions. Exact same things we ask the LLM. And then we're also going to ask the people, given the outputs, just preference order them across the 4 types of prompting. So a joke generated by basic prompting, a joke generated by human prompting, a joke generated by chain of thought reasoning, order them in your preference order. That's the second kind of evaluation that we did. As you can see, we asked people about the quality of the artifact, and that quality changes. For jokes, it's funniness. For poems, it's emotions. For stories, it's emotions also. And for the bigger stories, it's entertainment. And we asked them about novelty, and we asked directly about creativity too. And you can look at these in more detail if you want to later in the paper, but the punchline here is there's not very much difference across, you can't really compare domains directly, but there's not very much difference across the different types of prompting techniques. As you turn the prompting knob, the creativity characteristics, quality, novelty, and creativity directly, they don't really change. And in fact, the only statistically significant difference was the human engineered prompts were statistically significantly better than the optimized prompts, interestingly enough. Everything else, there was no statistical difference. For preferences, you can sort of see across the prompts, and not a lot changed either. Interestingly, although not necessarily statistically, there's statistical differences here. This one is worse than every other method, and the other methods are all statistically indistinguishable from each other. But you can just look at that, even though the statistical difference isn't there, the basic prompt is preferred the most, even though it's the simplest prompting technique. The results of that basic prompt are preferred as much as anything else. All the more complicated methods never generated things that were overall preferred any better than the basic prompting. That's sort of the punchline there. Also, another punchline that we noticed is, for the characteristic evaluations, that is the joke funny, is the story entertaining, is the poem emotional, is it novel, is it original, is it creative? The LLMs always overestimated significantly. Have a look at this picture. This is the human estimation of those characteristics. LLM estimation of those characteristics. All the bars are quite a bit higher. Most of the bars are quite a bit higher. The LLM overestimated how funny the jokes were, how interesting the stories were, how emotional the poems were, by a lot. Which, of course, means that the things it produced aren't so good, even though it thinks that they are. We also looked at the diversity of the embeddings of the artifacts. And they're not very diverse, as you can see, right? I mean, you can't really compare across domains again, but within the domain, you can see the diversity isn't really what you'd like to see. And in particular, you won't see that the different prompting methods don't look like the more complicated ones don't get things more diverse. They don't spread across the embedding space any better. They're not really doing what we'd like them to do. And these numbers say the same thing, actually. So, getting back to our question about, as we turn that knob of more sophisticated prompting methods, do we get more creative outputs? And the answer is, for everything that we did, no, we didn't really get that. But I just want to end by saying the real gotcha here probably is the kind of thing that Tony was talking about in his talk. This sophisticated prompting method where the prompt is automatically optimized to get better and better jokes over time actually works. The gotcha is that it's using an objective, automatic evaluation of the joke funniness that is only as sophisticated as the LLM's understanding of joke funniness, which is often not that great. So if you could have better automatic evaluation, something that better understood what makes a joke funny, the optimization is likely to work better, and the prompts are likely to work better, and you're likely to get more funny jokes. We haven't gotten there yet because we're stuck on this automatic evaluation problem, which is the same problem Tony was talking about. So for now, we can say this knob that we'd like to turn, just like the temperature knob doesn't seem to do the trick, neither does the sophistication level of the prompting seem to do the trick, at least so far. One thing we thought would be a next step that you might be able to do is, what if you think about replacing that objective function, that automatic evaluation of joke funniness, with something that does understand joke funniness, like people, right? And oops, that's my little thing telling me to shut up, and I'm about to do it. If you do something like this is a lot the way ChatGPT was trained to learn how to chat, using reinforcement learning via human feedback. And if you could do something like this for creativity, you could wind up building an LLM that is not a chatting LLM like ChatGPT, but an LLM that is a creating LLM. And that might be something interesting to think about. Okay, thank you.
We have a few more. Oh, we have a question.
Thank you for the talk. I'm curious. So, do different prompting mechanisms potentially have an effect on the temperature of the model that just maybe hasn't been measured? Instead of explicitly changing the temperature, is the prompt, fine-tuning the prompt or using a different prompting method indirectly influencing the temperature of the model?
That's a great question I don't know the answer to. I want to say I suspect that the answer is probably no for most of these kind of LLMs, because most of them allow you to fiddle with that temperature directly, so it seems a little counterintuitive to me for them to give you a knob to turn and then they're indirectly turning it without your knowledge. But I don't know for sure, so that's a good question. I don't know.
Thank you.
Do we have other questions? Yes, we do.
On knobs for creativity, do you have any thoughts on decoding strategies themselves as knobs?
The what strategy?
Decoding strategies.
Oh, decode. Yes, maybe. Certainly, maybe. But I think those are often not accessible to the layperson, right? That's why when we thought of, okay, what's the next knob to try if temperature isn't the right knob, we wanted a knob that anybody can use, and anybody can prompt an LLM, but when you start to open them up and fiddle with the decoding strategy or something like that, then it's at least a more sophisticated knob that is not accessible to most people. But I agree with you that this should be something we should think about as well.
Thank you, Dan, for the talk. I think that we discuss a lot about the definition of creativity inside the community, and it's very difficult in different groups to agree what creativity is. And by combining these definitions, what would be the definition of creativity that the LLM, it was provided to it, the definition of creativity, or it just was an open question, is it creative? or something like that.
So you mean for the automatic evaluation
Yeah,
that we
the
did?
automatic.
Yeah, so we ask it directly for jokes, for example. We ask it directly, is this joke funny? We ask it directly, is this joke original? And we ask it directly, is this joke creative? So in some sense, you might say those are similar questions. I mean, in the sense that we often think in this community anyways that novelty and utility or quality are the essence of creativity, but we ask it for both those things and creativity directly. And we ask people the same thing. I agree with you that it's tricky to say even what is creativity. So that's not something we're trying to solve here. And I think as a community, we've agreed we will never solve it, really. So we just ask these other questions and try to, I mean, if I could just get something to give me funny jokes, I would be really happy.
Thanks for a very intriguing talk. So I'm wondering about the initial generation of the artifacts. And I think you said you generated 100 artifacts in each of the cases. And I'm wondering, what do you expect would happen to the results you showed if you generated, an order of magnitude or more artifacts? The reason I'm asking is because, the quality of what comes out can often depend on sort of the seed of the generative process, like where did the model happen to start in the space. And sometimes you just end up getting stuck in kind of a bad local minimum.
Sure.
And so what do you think is the weight on, like, which of these would have a bigger effect on what you observed across the complexity of the prompting strategies?
So do you mean if we just asked for a lot more, would we get better ones?
Yeah, like, what do you think the chances are that, now we just undersampled the space and maybe there would be a bigger effect of prompt complexity if you just sampled more?
Maybe. It's certainly possible, right? And yet, I think the way we did this is we sampled 10 and rated them automatically, and then took the top one and saved it, and then sampled 10. So we at least had 10 restarts, right? And we did this a lot of times, and for the final study, that was our design. That's all we did. But the thinking here, I agree with you that if you sample a bazillion times, maybe you'll see some effect. I also think that you shouldn't need to sample a bazillion times, right? If the system really knows what it's doing, you shouldn't need to do that. Yeah. Yeah, I agree with you that if we ask for a lot more, maybe you're going to get a diamond every once in a while accidentally. But we'd like to build systems where you don't have to ask for 10,000 to get one, or 1,000,000 or 1,000,000,000.
If I understand correctly, you use this technique made by Google that optimizes prompts, basically, and they say whenever you use this technique, it should produce prompts that give better results. But your study also shows that a lot of your results are comparable to prompts or basic prompts. So is there a discrepancy between your paper and what Google claims, or is there a reason for sort of this difference?
Well, let's remember that the Google paper and the Google technique that we did, it gets better results as measured by the objective function that is in that loop. And the objective function for us was the LLM asking itself those questions, is this joke funny? And our results showed that over time, it does in fact get funnier by its own evaluation.
Right.
And that isn't a discrepancy with what Google said. That's exactly what Google saw too.
Okay.
But when we then ask people and we use other techniques, we don't see that this thing improved over them. But that's not because the optimization loop idea is wrong. It's because the automatic evaluation that we applied to optimize isn't measuring what we would like it to be measuring, I think. It's not actually doing a very good job of measuring funniness of jokes. So whatever it's optimizing isn't in fact joke funniness.
Right, okay, that clears it up, thank you.
Okay.
actually also wanted to ask about the variation in LLM responses to the idea of like, is this joke funny? In the same way, two people might think that one joke is either really funny or not funny at all. If you use different LLMs to evaluate the funniness of the joke, do you see like that kind of same discrepancy, that same variation between LLMs as people?
That's a really good question. I suspect the answer is for sure yes. We didn't do that here, so I can't say that yes. But I think that might be a thing to do for the automatic evaluation, is to have 10 LLMs all answer whether the joke's funny. That might be better. That might be a really cool idea, actually. We didn't try it, but I like that idea.
Thank you.
Time for one more question, maybe two. There's another.
I guess the LLM probably from the get-go didn't have a like good idea of like what's funny to a person and what's not. If you took an LLM and you actually fine-tuned it on like funniness, like kind of like separately, and then worked on that LLM, what do you think would the result be?
Yeah, that's kind of what I talked about at the very end, which actually a step beyond even that. Instead of fine-tuning the LLM on funniness, you train it with a reinforcement model kind of technique to maximize a reward model that is modeling human ideas of funniness. This is the way ChatGPT was trained to be chatty instead of just a language model, right? We took a bunch of humans and trained them, or used them to show what would be a good response to these kinds of questions, and then we built a reward model that models what those humans are doing, and then we use reinforcement learning to, I guess in essence, fine-tune ChatGPT, or GPT to become ChatGPT. We could do the same kind of thing, I think, maybe with joke funniness, or maybe even creativity in
So would it be kind of like researchers sitting down and evaluating like funny data sets, like, and then like talking to the system in a way where it's like, that's what's funny to people? And
maybe.
Then, like, kind of a feedback loop between the two.
Well, maybe. I'm envisioning doing it like ChatGPT, where we just have a bunch of people. It's an ill-defined problem, right? But if you could imagine a bunch of people saying, here's a funny joke, this is a less funny joke, this is a more funny joke, and then you could build a reward model that captured that adequately, you should be able to do something more sophisticated than anything we did here.
Right, thank you.
Great, we are out of time, but if you have more questions, you can ask our speaker later.
Thank you.
Our final paper is written by Andre and Felipe, and it's titled Experimenting with Large Language Models for Poetic Scansion in Portuguese, a case study on metric and rhythmic structuring. Let's welcome our speaker.
So, hello everyone. I think we could check the sound during the presentation because we have a small video. So, my name is Felipe Calegario, professor at Centro de Informática at Federal University of Pernambuco. Along with the university from the Southeast, we are on the ranking of the top 5 best computing degrees in the country. As a euphonist that we are in Pernambuco, I have to put this slide here. So I'm going to present our work on large language models for poetic scansion in Portuguese. But before I begin, I have to confess, today is the very day of São João, that back in Pernambuco, is one of the most beloved festivals in the northeast of Brazil. I have my shirt here, just representing the festival. And usually I would be back there dancing forró, eating corn, and this kind of thing. But instead, I'm here to present you, all the way from Recife to Campinas, to present you a little bit of the poetry that we have during the festival there. It was a very good coincidence to be here in this time. This is the work that we're doing with this poetic journey through our backlands, and trying to use large language models to help us analyze and support the metric structure of Brazilian folk poetry. And this research brings together AI and living traditions, and it's part of a broader project that I'm going to talk a little bit here, is the Pajeú project. But let's begin in São José do Egito, a small town in the heart of Sertão of Pajeú, is over there in Pernambuco, where there is the Pajeú River, and that's important. In the Pajeú region, improvisational poets called repentistas or cantadores gather in duel in rhyme. So there's even a saying, whoever drinks from the Pajeú River learns to rhyme. It's a very strong sentence that we have there. These duels, more than entertainment, they are a way of life, passing poetic forms from one generation to the next. And this culture inspired our platform's name and mission. Now we are going to see an expert of a video, and we're going to check if the audio it's okay, because it's important. It's a challenge between Lorival Batista, Louro do Pajeú, and Pinto de Monteiro, so two famous masters in the art of cantoria. And this video is from 1969. Just let us see if the video...
Vontade perdida em machucar, eu não machuco. É Pinto da Paraíba, em Lorival de Pernambuco. E macacos da nossa idade não botam a mão no combo. E a coisa que não te subo na minha perna não vai. Chegando eu volto pra fora e rapidamente ela sai. Aonde eu estiver cantando, de falta ninguém não cai. É isso que me distrai, eu terminar com mais fé. Que ali já deram sinal pra o filho de São José. Eu vou tomar outra picada e Pinto tomar o café. Quem pra isso não nasceu, não pode cantar repente. Não sendo bem consciente, não tem pensamento seu. Também não imita o seu, e nem nasceu no sertão. Não trouxe essa inspiração, que vem da parte divina. Sem vontade não combina, e lá vão de terra quadrão. Essa ordem não me dê, que meu pensamento é rico. Eu pulo nas suas penas, arranco canhão e vivo. Eu vim do meu Pajeú, pelar o seu sobrico e lhe deixar
So I tried to show three different genres of the duel, the peleja that we have there. There are some specific forms that we have in each genre. So the pillars of the cantoria, we have the rhyme, the meta, and the meaning. And in this tradition, the poets have to master in an improvisational way. You have to improvise with these skills. Here we can see the beautiful stanza by João Paraibano. It's a décima, which means it has 10 verses. In this example, each verse has 10 poetic syllables. The poet has to match the stressed syllables in the right place to keep the rhythm. Da, 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 da. You have the rhythm in the back. These improvised vests require not just creativity, but a rigorous training in these metric rules. Let's look at Zé Limeira, the legendary poet of absurd. He would recite verses like, ano passado eu morri, mas esse ano eu não morro, which the translation would be, last year I died, but this year I won't. Skillfully playing with rhyme and meta, so it's a perfect sentence in metric, but often stretching the meaning for comic effects. So we've made this persona just to make sure that we communicated in a good way our system. Let's picture Pedro, a young poet in Pernambuco, writing his first martelo agalopado. He's a genre of cantoria on his smartphone. He has an idea, feels the rhythm, but struggles to count poetic syllables, especially with tricky vowels fusion that we have in Portuguese. That's where our work comes in, turning poetic tradition into digital support, so Pedro can get feedback on his verse, rhymes, and matter, allowing him to practice the skills anytime, or could be anywhere. The Pageu platform that I'm talking about plans to offer, it's a good point. Rhyme lookups, visual prompts to inspire poems, telematic prompts for writing challenge, speech-to-speech duels against the system, and at the heart of this talk that I'm doing today, this is the small part of this platform that's the instant metric validation powered by a fine-tuned language model. The idea is to put the tools of a master poet into our hands while respecting the oral and social nature of the art. So just put in context, it's interesting because I have the author here in front of me. We have in computational poetry platforms like Poetry.me, and its extension allows users to generate Portuguese poetry using modular templates and other approach. And they are great for creation, and we see as a complementary work since we focus on analysis. When it comes to language models and poetic text, there are several creative examples. For example, the Google's text effects lets user play with words and rhymes in English, other projects in English and Spain, but Portuguese has its specific challenges. And even though it's not directly related to poetry, the Sabia model that is fine-tuned for Portuguese is very important for us because it can show that it's possible to get high-quality results without starting from scratch for Portuguese. And finally, let's talk about this work from 2016. That's the system AOIDOS, introduced automatic rule-based poetic extension for Portuguese, but it only works in a stanza level. So it tries to force the syllables in a stanza level, which makes not suitable for real-time verse-by-verse extension that we are planning to provide in Pageu. So for our research, AOIDOS corpus provided our gold standard. We just passed the stanza to AOIDOS and then extract the verses already with the division. And in our work, we codified scansion in these terms here. Let's take the line, nos verdes ramos. We break it down, nos verdes ramos. The last syllable we don't care because it's the last. It's not poetics. We don't count it as a poetic syllable. We have then in this sentence 4 syllables only. Even though if you analyze it morphologically, syntactically, it would be 5 syllables. But we are interested in poetic syllables here. So we have we explored 2 main approaches for teaching a language model. The first one was prompt engineering with this approach, this sub-approach there, zero-shot prompting. There's simply telling the model what to do. few shot prompting, showing examples, and chain of thought, guiding it through step by step, and this is an important thing. It's different from the chain of thought that Dan mentioned before. This is we are guiding the model to do something. We're not using any kind of language reasoning model. And finally, fine-tuning training directly on annotated verses. Only the last approach could really cross the finish line for us, as we could see in the next slides. In zero shot, it was made basic mistakes, breaking words in wrong places, and it was not that good. Few shot prompting helped a little bit the syllable boundaries, but still had trouble with stress patterns. And the chain of thought, the model couldn't handle the tricky aspect of pronunciation and phonetic fusion, so we just dived into the fine-tuning setup, because it interested. Fine-tuning is good for abilities. So we're teaching a new ability to the LLM. It's not related directly to new knowledge. That would be, for example, retrieval augmented generation or something like that. So consider our fine-tuning step. We used GPT 3.5 Turbo as our base model, fine-tuning it on the verses scanned by the rule-based Aoedo system. So this is a tricky one, because we are inheriting some of the problems that they already have. We run 3 epochs, and at inference, we set our temperature to 0.1. We use 2 strategy, iterative with 18 steps, and single pass. When we were fine-tuning, that's important to say, we are cautious about the spending too much. So we have a very limited budget. So we are unsure of the quality of the results, so we wouldn't go in a very big data set. So we took a step-by-step approach, starting with 40 examples, and then iteratively trying to improve the model with caution because of the money. And the other approach was a single pass one, and we are in a different approach. We know already that the other one is working, so let's be a little bit risky right now. It was a single pass approach. We ran fine-tuned once with more than 3,050 examples for validation. So the result with the iterative approach, we achieved the best result of 88% exact syllables. So comparing to the Aoedo's database, we have this exact syllable division in 88%. But if we are tolerant, and if you go 1 syllable plus or minus, we can improve to 97%. It's not, well, we're just opening a little bit the tolerance there, but we could achieve this 97%. Considering the cost, that iterative fine-tuning costs around $116 in that scenario, but a single pass with similar results was under $7. And at inference, each verse costs about 200th of a cent. That will be okay for an entire festival of poetry. That will be okay. So in our experience, fine-tuned outperforms prompt engineering. Accuracy gains plateau against rising costs. Still, challenges remain. For example, the vowel fusion is still tough for AI. Aoedo's limitation because of the stanza level maybe had some impact on the results. And I have to mention this vendor lock-in, that as we rely on the commercial API of OpenAI, our model is in the servers. We cannot get the model. Is there. I have to pay to use the model I trained. This is not that good. So for long-term sustainability means we may need to migrate to open source model in the future. And finally, we live in a fast-evolving LLM, GPT 3.5 Turbo, maybe in an old model, these days currently. So we consider it doing in new models too. For future research, we look forward to plan expand the corpus with annotated verses by humans, fine-tune more traditional forms like decimas and sextillas. We have a bunch of different genres, and integrate semantic and original rhyme, because we're just dealing with metrics here. With retrieval augmented generation, we can put some themes and get some elements for providing ideas, and add speech synthesis. That will be the most difficult part, to get the rhythm they have there in Cantoria. Is something that we are quite interested in doing. Even if you see me listen to my accent is different from the people here in the south, so we don't want to get the base model that's always modeled up from the southeast perspective. The accent that they have in the voice in those models are from the southeast, and it's not that good for our experience back in the northeast. So in our experiments, fine-tuned achieved promising Portuguese scansion accuracy, enables metric validation and guidance within the Pageu platform. That was our main goal, is to build this bigger platform. And here's just a small, tiny piece of this. And well, the takeaway, the AI can count the steps of a verse, but we believe only living poets know when to stumble on purpose. That's a very interesting thing. They do it majestically. They just stumble with the metric and plays like a dance. And all of that improvising, that's a very important thing to remember. And our hope is that the Pageu platform can help keep poetic traditions alive by supporting human creativity. So, thank you very much. I'm open for questions.
Do we have any questions? Yes.
Hi, Felipe. Thank you for your presentation. It's very good to know that someone is working on this kind of things for Portuguese. Nice. I have, well, one question, because I think I know the answer to the other. You didn't compare with other language models. You said it yourself, because of money issues. But have you tried comparing these results with rule-based tools?
Nice.
Or maybe even combining, looking at the issues that the models have, where doing something like an error analysis, and see if these issues can be fixed by just a rule or a simple
well, I believe
fix.
Yeah, the combination of rule-based systems and the LLMs, I think is the best approach to do this kind of thing. That's related to ability. It's like you have to apply some rule, and you have to the result. We indirectly come from a rule-based tool that's Aoidos. It's a tool developed in the south of Brazil, and we didn't get back. We didn't put the loop back into the Aoidos to match. That's a very good approach to compare. And then, but we didn't do that. And then maybe in the next steps we can do that.
Yeah, I have other things to discuss, but we can do it
later. Perfect.
Thank you.
A quick question, something that Hugo maybe knows already, but I don't. Why didn't you use a Portuguese language model, the Sabia open source that you mentioned before? Wouldn't it be better?
We didn't have it available at the time we made this experiment. After that, we get a grant of 500 reais that we already have, so we can use the newest version, that's the Sabia 3. That's also developed here in Campinas, so we are, but back then we didn't have the access to that. And we had a small grant in OpenAI, so that was money issues. Yeah, but it's important task to do. We don't know, basic because of the thing that Pablo was saying, that maybe the fine-tuned it doesn't relate to the syllables, it more like related to tokens, and we don't know, we have to experiment to have this kind of statement that it's better or not. But it's in our plans to do, as the grant we have already.
Do we have any other questions? Going once, going twice. I have a question. So, if you had more time or resources, what would you have done differently?
Today, we would have used the reasoning models to see if there is any kind of difference. And maybe O3, you're saying about limited resources. Okay, yeah. So we'll use O3, and with different approaches, we have already the prompts and this kind of thing. So we'll test, and then we would use the rule-based just to match if the result is aligned or not. That we have a bunch of very, very costly and very expensive models, and I would be quite interested because they are expensive for maybe code generation or this kind of approach, but for this specific task, would be better or worse? It would be interesting to see.
Follow-up, if we have unlimited resources, we could probably try to train one model from scratch on the token level or syllable level, and
unlimited resources we can do. Okay, I wasn't quite imaginative because in my head, training from scratch is just for big companies, big tech companies. So that's the limitation. But it's a good exercise. Yeah.
Anyone else? No. Okay. Well, we can break early for lunch. Oh, you're just ready.
Ready to clap.
Yes. Okay. Let's thank our speaker.
Thank you very much. Thank you very much.